Okay, welcome to another episode of Crimes Notes. At this point, you should be getting pretty familiar with this. So as usual, at the top, there are two problems for you to do now, which is on your own, that are a review of our previous notes. So complete the following exercise. Look at this problem. Would you combine like terms or would you distribute? And then why did you choose the option? And then go ahead and do what it is that you should do and simplify the problem. And then on the right-hand side, simplify the expression. Here's the expression that I want you to simplify. Make sure that you've combined all like terms. Okay, sorry, I gotta take a drink. I got a hairball or something. Okay, so after that, this one is a little bit different. If you look down here, it says things to ponder. And what I want you to do is I want you to look at the first equation, and then I want you to look at the second equation, and then I want you to tell me on these lines what changed. So again, look at this equation, and tell me what changed. You kind of used to do this back in the day when you had those little books that would say find the different things between the pictures. That's what this is. So don't think very hard about it. I just want you to look and tell me from here to here what changed. Same thing here. I want you to look at this. I want you to look at this. Tell me what changed. Look at this. Tell me what changed. I think you're kind of seeing the pattern. Look all through here. So then, using all of those as a pattern, I want you to look at this equation right here, look at what I put right here, and see if you can't write your own equation and tell me what changed. And then over here, I want you to make up your own and tell me what changed. Okay, so that's all just kind of food for thought before you get into this video. So go ahead and pause the video right now and get that done first, because that's the setup for these notes today. So if you haven't done that, you're not ready to move on. All right, so that means we should be ready to look at our vocabulary down here at the bottom. And since today's notes are over function notation, our first vocab is function notation. And I know it's kind of little on your screen, but luckily you can see it on your paper. I've given you an equation and it says f of x. Notice it tells you this is read as f of x. And f of x is the same thing as y. So this equation, f of x equals 9 minus 4x, is the same thing as y equals 9 minus 4x. Y and f of x are equivalent, meaning it's the same exact thing. So we read this f of x. This is not multiplication. So again, that might be something that you put on your notes to self. F of x is not f times x. Okay, it is a function notation. F is the name of the function, so we can use whatever letter that we want to. So if we had, say, a golf course named Timber Creek, we could call this T of x, or anything of the sort. So F is the name of the function. X is the input variable, meaning it's what I replace in the equation in order to get solutions. So going back up to what you had up here, that's what you should have noticed, was that f of x here, if I replaced x with 10 here, then everywhere in the equation it was replaced with a 10. Okay, so hopefully you kind of figured that out, but if you didn't, now you can kind of go back and do that. So what's the purpose? Well, the purpose is that it gives us a way to distinguish equations from each other. So it gives us a way to distinguish multiple equations. Because we can give them a name. So it's kind of the same thing. Technically, if you have a bunch of kids with the same name in a room, you usually start to give some of them a nickname. So let's say we had 2 Joshuas. Well, you might call one of them Joshua and one of them Josh. Or you might call one of them, you know, whatever their last name is, and call the other one Josh. So you find a way to distinguish between like things. And that's what function notation does. Okay? And then again, we have this, and I really just wanted you to know, again, that this is read f of x. And I expect you to be able to use that language. Okay? And again, this is the input variable, so what we put in is x, what we get out is f of x. So normally, if we were to write an ordered pair, we could write it as x, y, but if it's f of x, we would write it as x, f of x, meaning that the x value, whatever we put into the equation, so let's say I put in a 2 here, whatever I get would be my f of x or my y. Again, y and f of x are interchangeable. So let's look at how this works. Sadly, I punched a hole right where your problem is on this one, so we're going to have to kind of rewrite it. But it was g at -2. So this is something that you have done before. So just like up here at the top, whenever you were doing this, you were basically taking whatever was here. So we took the x and we replaced it with an a. That means in the equation, I replaced x with an a. So when they're asking us to evaluate, it's going to be the same thing. So down here, this says I need to find function g and replace x with -2. So if I look, here's my 4 functions. Here's function g. So if I'm replacing x with -2, that means this is going to equal 2 parentheses, because again, side by side means multiplied, so I would use parentheses, -2 squared minus 4. And then that's calculator ready, so I could just plug it in. 2 parentheses -2 squared, and then minus 4. Again, when you're using the calculator, make sure that this squared, that you come down. You don't want this 4 up as an exponent. Okay? And then press enter, and it gives me an answer of 4. Whoop. So g at -2 would be 4. So what about h at 36? Well, I've got to find function h and replace x with 36. So I'm going to input 36 as x and see what my output is. So h at 36, here's h. So I would replace x with 36, and it's still over 6. And then we could put that in our calculator if we needed to. So 36 divided by 6 is 6. So h at 36, 36 as an x, 6 would be the y. So again, if I was writing ordered pairs for these, and I'm going to do it in a different color just so you don't think it's part of the work, but if I was going to write an ordered pair, this would be -2 for x and 4 for g of x, or y. So the same thing here, if I was going to write an ordered pair, my x was 36, my y was 6. So we could write ordered pairs for every problem. What we plug in is the x, what we get as a result is the y, and these are actually points that we could plot on a graph. All right, so let me see. I don't want to necessarily do all of these for you. I think you could plug 0 into this one. I'll set up this one, but I'm going to have you finish it. So f at 1/7. So if we go back, here's f. Here's my equation. So I'm going to replace x with 1/7. So it would be 7. Side by side means multiplied. So I'm going to replace and multiply, and then minus 1. So from here, you would be ready to put it in your calculator. H, this one, same thing. I'm going to help you set it up, but I'm going to have you put it in your calculator. So this one is a little bit odd because here's my fraction, right? Here's function h. X is on the top. So I have 1/6 on the top of my fraction, and I have 6 on the bottom. Okay, so I totally lied because I'm going to show you how to put this in the calculator. So when you're going to put this in, you're going to want to go to this crazy button over here by the 9 so that you can find your fraction. So right here in that top row is your fraction, so that in this top you can put your other fraction. So you would do 1 divided by 6 so that you've got a fraction in the top, then go to the bottom and hit 6. Now when I type enter, it's going to readjust this, but here it is. And so now it looks kind of crazy, but notice that this bar is shorter than this bar. So you know that this is 1/6 divided by 6. And it tells me that the answer is 1/36. So we would put 1/36. And that is an answer. It may not be pretty, but it is an answer. Okay? All right, so the last thing we need to talk about is what if there's a negative like these two in front. Sorry, of course my phone's not on silent. Story of my life. Okay, so on this last part, we're going to take the same thing. So we're going to pretend that that negative isn't there. We're just going to write it down. So here's the negative, and then we're going to do everything the same that we would have before. So this is 3 parentheses x, which is 3, squared, minus x, which is 3, and then plus 2. And now you could type this in exactly like it looks. So you would have negative parentheses 3, open parentheses 3, close, squared, and then minus 3 plus 2, close parentheses. Press enter and it tells you the answer is negative 26. Good. So I've kind of left 3 of them for you to do on your own just to test before we get you an assignment. Okay? I know that there is a back to these notes, but I'm not asking you to do it right now. So you're just going to do the front. We've got some other stuff to work on, and then you can go and watch the video for the back. All right, you guys have a great day.